Okay, so now I'm giving you a graph and I'm going to tell you, I want you to determine what is the inequality here. So in other words, give me the equation. So looking at this, first thing that I would detect is I would detect that that's a dotted line. So that tells me I'm going to use either that symbol or I'm going to use that symbol. But which symbol is it? Well, think about this. This is your fence. And if you think about it, you're below your fence. So if you're below your fence, you want all the values that are less than. Of course, you want your values of y to be smaller than whatever the equation of your fence is going to be. And you know your fence is a line, so guess what? mx plus b, baby. There it is. Now, easiest way to do this, find me some points that work. There's a point that works, and you know what? Oh, that looks like a point that works right up there. You could choose other points. You could choose this one down here. You can choose that one. It doesn't matter. As long as it's on the graph, you're good to go. So I'm going to choose this one here, and I'm going to choose this one here. Okay, so my slope, rise. 1, 2, 3, 4, run 1, 2. So my slope is rise of 4, run of 2x. My y-intercept, of course, is going to be plus 4. And I think that's what my equation is supposed to look like. Let's clean it up. Y's got to be da-da-da. 4 divided by 2, that's 2x plus 4. There's my equation. But I want to prove this because, after all, I have a graphing calculator. I want to use and prove that that's the exact calculator. I better graph this. I want this, including all this beautiful shaded stuff here, in order to prove that I've got the right answer. So first things first, I'm going to go to my calculator right there. And look, I already have the 2x plus 4 that I had originally up here. Look, there's the 2x plus 4. There's the 2x plus 4 blinking away. I'm going to use my zoom, standard zoom 6, and I'm going to actually draw this thing. But notice, there's no shaded region. Ah, rats. But here's how you do it. Simple. Go into y equals 2. Mouse over. You're going to get this. Now, if you've got the older calculator, all you have to do is keep hitting enter, and it changes all kinds of different things. If you hit enter, look what you can do. You can change the color of this line to be whatever you want. Wow, look at all the different colors you've got down here, which is kind of neat, okay? Now, let's do the light blue. I don't care, but here's the interesting point. Look at this. I can change what happens to the line. I can change this to, guess what? That would be shading upwards. That would be shading downwards. Aha! Interesting. And if you do this with the old calculators, just keep hitting enter, enter, enter until you get shade up or shade down. Then, on this one, you got to hit OK. And watch what happens when I graph this thing on right there. Check it. Da-da-da-da! Isn't that cool? It does all the shading for you. But here's the problem. Notice that this guy does still give you a solid line. That's the problem with this graphing calculator. Again, when you get into engineering and you get into computer engineering, design me a decent calculator. That should not be a solid line. That should, in fact, be one of those beautiful dotted lines that we have here all the way through. That should be dotted. That's the flaw of this calculator. It doesn't do a dotted line like that. So that's how you graph this. That's how you prove it. Watch this. I'll show you. Exactly the same thing that I had. It's kind of cool now that you can use your calculator to do some shading.